Okay, very good afternoon, one and all. Okay, actually the strength is very poor. So almost all it is 211 and only 12 students have joined. Okay, strength is very poor. So please inform your friends to be on time because session is from 2 to 4, not from 2:30 to 4. Okay, so please inform your friends to be on time. Okay. Okay, so our coming to our syllabus, this unit 4, we have split this unit 4 into like 4 modules, and each first module is the concept of information and its properties, and in the second module we discuss the entropy and its properties, and in the third module we discuss the information rate and its properties. And coming to the fourth module, in the last class we have started the introduction to marginal, joint and conditional entropies. Okay, so we have gone through the basic derivations for expressing the marginal entropy, joint entropy and conditional entropy. So in the today's class, we can interrelate all these entropies. Okay, these relations are very important. Okay, so we can start so already I said you that coming to the marginal entropy. So marginal entropy is a one. It's also the average information content present provided by the discrete memoryless source. Um, for example, h of x be the marginal entropy for the events that occur for the transmitter section. Here we are considering the real life example of a communication system. I think we know that it consists of transmitter, channel and receiver sections. Okay, h of x ఏంటి represent చేస్తాం? It's a marginal entropy. So it is for the transmitter section. It's the entropy of the transmitter section. So entropy, like our transmitter section consists of capital M number of messages or events. So those events x1, x2, s3 up to so on, x suffix capital M. For the subset xj, where j ranges from 1 to m. And h of y, let us assume h of y be the marginal entropy For the events that occur for the receiver section, y ranges from y1 to yn. Okay, so for the subset small yk, where k ranges from 1 to n. So based on the transmitter section and receiver section, based on the transmitter section and the receiver section, we have defined the corresponding marginal entropies as h of x and h of y. These are the general marginal entropy. This is not a combined entropy. That's like joint entropy. Here you can see h of x. It is defined as it's defined for the transmitter section events, capital X. So that's why it is represented as minus summation j is equal to 1 to m p of xj log p of xj base 2. Now here, if you know the p of xj matrix, so because p of xj matrix, if it is given in the problem, automatically you can solve the entropy of the transmitter section. So for example, it would be p of xj, capital M 3 ichar anukondi. So p of xj, for example, 0.4, 0.4, 0.2. So sum of all the values is, all the probability values is equal to 1. So apart manaki p of xj, so p of x1, p of x2, p of x3. So by knowing the with the p of xj x matrix consisting of summation j is equal to 1 to m p of xj. So upon knowing the p of xj values, directly you can calculate the entropy of the transmitter section or the entropy of a particular event capital X. Similarly, how can you calculate the entropy of a particular section capital Y? Capital Y. So this is we consider it as a receiver section. So it will be minus summation k is equal to 1 to n p of yk log p of yk base 2. Okay, so if you know the values of p of yk, so matrix, if it is given to you, automatically you can solve the entropy of receiver section. Okay, so this thing we studied in the last class, and also I told you that for example, if S1 with the signal space representation of transmitter section, where if you observe the figure, S1 is the signal space representation of transmitter section consisting of events x1, x2, x3 up to so on x capital M, x suffix capital M. Similarly, here you can observe S2. It is the signal space representation of a receiver section capital Y, whose events are y1, y2, y3 up to so on yn. Here we considered k as a variable. So that's why I mentioned here as yk. And similarly, if you observe the first figure, I mentioned as xj. Okay. Similarly, you can observe S1, S2. It is the like signal space representation of the combined event due to both transmitted data and receiver data. That is xy is xj yk, where xj j ranges from 1 to m and k for yk k ranges from 1 to n. Okay. So already I told you, based on the marginal probabilities, we can calculate the marginal entropy. So p of xj and p of yk are the marginal probabilities. So if you know the respective probabilities, you can calculate the respective marginal entropies. So if you know p of xj, you can calculate h of x. If you know p of yk, you can calculate h of y. So here we are representing the marginal probabilities in terms of joint probability. So p of xj is summation k is equal to 1 to n p of xj comma yk. ఇక్కడ ఏం చేస్తున్నారు? This is joint probability. Here we are replacing the joint probability in terms of marginal probability. So if you want to do like this, k is equal to 1 to n. So here yk you are replacing. K equals to 1 to n, yk you are replacing. So automatically you will get p of xj value. And if you replace j value that is from 1 to n, you can get p of yk. Okay. So here you are representing the marginal probability, our joint probability with respect to the marginal probabilities. Okay, this first equation represents the relation between the marginal probabilities and joint probability. Okay, so joint probability is generally represented as P of xy, capital XY. So where j ranges from 1 to n, k ranges from 1 to n, P of xj yk. Already I told you that x is a, here if you observe, it is a column vector. Okay, so single column vector m by 1 having m number of rows. Okay, and y is a receiver section which is a single row vector consisting of n number of columns. Because at the transmitter we'll have series to parallel converter and at the receiver we'll have parallel to series converter. Now if you multiply these two, you can get the joint probability matrix as first row elements enti x1 y1, x1 y2 up to so on x1 yn. Second row elements are x2 y1, x2 y2 up to so on x2 yn. Similarly, we have m number of rows and n number of columns. And the last element is xn yn. Okay, so this is the joint probability matrix. Okay, remember these values. And joint entropy, it's the combined relation, events relation that occur for the transmitter section and receiver section. So what is the expression for joint entropy? We defined it as h of xy is equal to minus summation j is equal to 1 to n, summation k is equal to 1 to n, p of xj comma yk log p of xj comma yk base 2. So once you know the probability, joint probability matrix, automatically you can calculate the h of xy, that is joint entropy. So knowing only, so if you know the joint probability matrix shown in the last slide, so this matrix, if you know this matrix, automatically you can calculate the joint entropy. So that is minus summation j is equal to 1 to n, summation k is equal to 1 to n, p of xj yk log p of xj yk base 2. Okay. Let us move to the next slide. So already I told you there are two types of conditional entropies. Okay. Okay, already I mentioned you there are two kinds of conditional entropies. One is h of x by y. This represents the or you can say that this entropy evaluates or calculates the parameters of the transmitter section. At a numerator, if you observe, it is capital X. It evaluates the parameters of transmitter section by knowing the denominator mentioned value. Denominator, you mentioned the receiver events, capital Y. So knowing the capital Y events, we are calculating the capital X events. And this conditional entropy evaluates the performance like parameters of transmitter section knowing the receiver events, knowing the information about the receiver events. Okay, so in this slide you can see that we have derived the expression for conditional entropy of the transmitter section knowing the receiver events. That is h of xy. So already I told you what is the first step. So here we'll represent the conditional entropy in terms of average conditional entropy h of x by yk at kth event of y. That is h of x by y is equal to summation k is equal to 1 to n p of yk h of x by yk. Okay, here h of yk represents calculating the it's the entropy that calculates the transmitter parameters knowing only ykth event. Okay, malli second step em cheppam. So second step is, first step is we representing conditional entropy in terms of average conditional entropy. So second step, we are defining the average conditional entropy. So what is the definition for average conditional entropy? H of x by yk. We are representing it as minus summation j is equal to 1 to m p of xj by yk. Mean that here we are calculating all the transmitter events. అందుకని చెప్పి x j అని చెప్పి represent చేస్తారు. Where j ranges from 1 to m. P of xj by yk log P of xj by yk base 2. Okay. So two steps. First step is representation of conditional entropy in terms of average conditional entropy. Second one is representing the average conditional entropy. So expression ఏంటవుతుంది x is here calculating capital X knowing yk. So అందుకని denominator yk is constant. And here we have only summation of transmitter section. అంటే j ranges from 1 to m. P of xj by yk log P of xj by yk base 2. Okay, now please substitute equation 2 in equation 1. Okay, please replace average conditional entropy using equation 2 in equation 1. Okay, what we did here, just we substituted average conditional entropy expression, that is P of xj by yk log P of xj by yk, where summation j ranges from 1 to n, in the overall conditional entropy expression. Just a substitute chesaru ante. Next what you did, we used Bayes theorem. So Bayes theorem states the relationship between, relation between the marginal entropies. What are the marginal entropies? P of xj, P of yk. Relation between marginal entropies, joint entropy, that is P of xj comma yk, and marginal entropies, marginal probabilities. What is the marginal probability? P of xj, P of yk. What is joint probability? P of xj comma yk. What are conditional probabilities? P of xj by yk, P of yk by xj. So Bayes theorem states the relationship between marginal probabilities, joint probability, and conditional probabilities. Okay, now please replace, here we have, so if you observe this equation carefully, here we have P of yk into P of xj by yk. So if you make use of this expression directly, here you need P of yk and P of xj by yk matrix. In other sense, you can also replace this as P of xj comma yk. Okay, so we replaced this, and finally we obtain the overall conditional probability of transmitter section, knowing the receiver parameters is minus summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk log P of xj by yk base 2. So if you observe this equation carefully, overall conditional entropy, if you want, you need two matrices. One is joint probability matrix and other is, one is joint probability matrix and other is conditional probability matrix. So joint probability matrix is P of xj comma yk and corresponding conditional probability matrix is P of xj by yk. Okay. So this is the first type of conditional probability. So second type, that is h of y by x. So because already I have completed this portion in the last class, I request any one of the student to please revise this concept, because anni almost malli revision chestunnanu. So I request any one of the student to revise the derivation for h of y by x. Any one of the student. And the procedure is almost all similar to h of x by y calculation. Okay. So any one of the student Any one of the student to please tell me the procedure to derive the expression for conditional entropy. మా ఏంటి ఉన్నారా లేదా? Any one of the student, please tell me the procedure to derive the expression for h of y by x. So I explained it in the last class, and now also I revised the expression for h of x by y. Can you please tell me the procedure for calculating the conditional entropy? M9 M9 L9 L9 K5 K5 J4
Yes, ma'am.
ఏమ్మా మీ ఫ్రెండ్స్ ఉన్నారా? పుణ్యావతి ఉన్నారా మీటింగ్ లో?
ఉన్నారు మ్యామ్.
మరి ఏంటి అట్లీస్ట్ రెస్పాన్స్ లేదు? దీనికి సొల్యూషన్ ఏంటి చెప్పు నువ్వు. పుణ్యావతి
మేడం
చెప్పమ్మా ఏంటి సొల్యూషన్, ఏం చేద్దాం మరి? యాక్చువల్లీ నంబర్స్ ఆర్ దేర్, బట్ వై దే ఆర్ నాట్ రెస్పాండింగ్? ఓకే చెప్పండి, మీరు చెప్పండి. కెన్ ఐ ఎలిమినేట్ దెమ్ ఫ్రమ్ ద మీటింగ్? అదర్వైజ్ కెన్ ఐ మార్క్ దెమ్ యాజ్ ఆబ్సెంట్? అమ్మా
I'll tell them, ma'am.
ఓకే
చెప్తాను
ఒకసారి నోట్ చేసుకోండి. L9 M9 అండ్ K5.
ఓకే మ్యామ్.
ఓకే K5 maybe he is not in meeting, so L9 and M9 are you there or not? My L9 and M9. ఓకే ఓకే అమ్మా మీరు చెప్పండి. ఆల్రెడీ లాస్ట్ క్లాస్ లో చెప్పాను కదా ఈ డెరివేషన్. సో హౌ మెనీ స్టెప్స్ ఇట్ విల్ హ్యావ్? ఓన్లీ 2 స్టెప్స్. ఏంటంటే అవి చెప్పండి చాలు.
First we'll write the average conditional entropy, ma'am.
Okay. First, we'll write the conditional entropy expression in terms of average conditional entropy. Okay. So h of y by x
Ma'am,
is
and
summation j is equal to 1 to m p of xj into h of y by xj. So here average conditional entropy is h of y by xj. Okay. Cheppamma.
in that expression, we'll write the p of y by xj equal to uh, p of y by xj into y2 by xj and so on up to yn by xj, that equal to summation k equal to 1 to n p of yk by xj. So
So what is the expression for average conditional entropy? Average conditional entropy of calculating the receiver parameters by knowing the xjth event is defined as minus summation k is equal to 1 to n p of yk by xj log p of yk by xj base 2. So now you have equations 1 and 2. So what is the next step?
average p of p. Madam,
అమ్మా చెప్పండి చెప్పండి.
here equation 2 will be substituted in the equation 1. Now we'll get h of y by x is equal to minus of summation j equal to 1 to m and k summation k equal to 1 to n p of xj into p of yk by xj log base 2 to p of yk by xj.
Okay.
Here by using the Bayes theorem, we know that p of yk into p of xj by yk is equal to p of xj into p of yk by xj is equal to p of xj comma yk.
Okay.
By replacing those terms, we'll get h of y by x equal to minus of summation j equal to 1 to m and summation k equal to 1 to n p of xj yk log base to p of yk by xj.
Okay. So to calculate the conditional entropy, how many probability matrices you need?
2, ma'am.
2. ఏంటంటమ్మా?
P of xj and P of yk by xj.
Okay, P of xj comma yk. What is this probability matrix called as? This one? P of xj comma yk matrix. Joint probability matrix. Okay. What is this P of yk by xj matrix?
Conditional marginal, ma'am.
మార్జినల్ అంటే సింగిల్ అంటే ఏదో ఒక ఈవెంట్ ఏదర్ ఎక్స్జేది కానీ వైకేది కానీ బట్ ఇక్కడ ఈజ్ ఇట్ మార్జినల్?
Conditional probability, ma'am.
కండిషనల్ ఆఫ్ క్యాలిక్యులేటింగ్ ఏ పారామీటర్స్ ని క్యాలిక్యులేట్ చేస్తున్నారు?
yk
yk ని క్యాలిక్యులేట్ చేస్తున్నారు అండ్ యూ నో ద వాల్యూస్ ఆఫ్ xj. So p of yk by xj, okay, represents the probability matrix, conditional probability matrix of calculating the yk values knowing xj events. Okay. Okay, ma. Thank you. Here you can observe all the 5 equations that what we have studied. Okay. So first one represents the. So I request any other student to please read because every time I am reading and I don't know whether you are listening or not. I will call roll number I1. So if you did not respond, I will mark you as absent. Okay, I1. I1. I2, I2, ma I1, I2. Can I mark both of you as absent? J2, J2, J3.
Madam,
Okay, marvelous. Thank you. Can you please tell me the expressions for all the types of entropies shown here?
yes,
So read
ma'am.
చేయండి అవన్నీ.
Marginal entropy of transmitter is h of x is equals to minus summation j equals to 1 to m p of xj log p of xj base 2.
Okay. Please tell me what is
Marginal
P of xj? What is P of xj? P of xj is the marginal probability matrix.
marginal probability.
Okay, of the
Yes,
transmitter events.
yes.
Okay. Okay, read the other ones.
Marginal entropy of receiver h of y equals to minus summation k equals to 1 to n p of yk log base 2 p of yk. Joint entropy of transmitter and receiver h of x comma y equals to minus summation of j equals to 1 to m summation of k equals to 1 to n p of xj yk log base 2 p of xj comma yk. Conditional probability of a transmitter knowing the receiver data is given by h of x by y equals to minus summation of j equals to 1 to m summation of k equals to 1 to n p of xj comma yk log base 2 p of xj by yk. And
Okay.
conditional entropy of a receiver knowing the transmitter data is h of y by x equals to minus summation of j equals to 1 to m summation of k equals to 1 to n p of xj comma yk p of yk log base 2 p of yk by xj.
Okay, my question is, please tell me what is the matrix size of P of xj? What is the matrix size of P of xj? Can you please tell me what is the matrix size of P of xj?
M by n.
M by చెప్పండి అమ్మా. M by 1.
1.
M by 1. Okay.
Yes,
P of yk, can you tell me the matrix size of P of yk?
1 by n.
1 by n. ఇక్కడ ఆల్రెడీ చెప్పాను కదా లాస్ట్ స్లైడ్ లో.
Yes,
So here you can see. So matrix size of P of xj is m by 1 and matrix size of P of yk is 1 by n.
1 by
What
n.
is the matrix size of P of xj comma yk?
M by n.
M by n. Okay. So if you know the matrix size of these three probability matrices, those are marginal probabilities. Okay, P of xj and P of yk, and joint probability matrix P of xj comma yk. If you know the three matrices, automatically you can calculate the conditional probability matrices, namely P of xj by yk and P of yk by xj. So how to calculate another we can see while doing the problems. Okay. So first
Yes,
three,
ma'am.
okay, three probability matrix you should know. So that P of xj is a m by 1 matrix size and P of yk is 1 by n and P of xj comma yk is m by n. ఈ three matrices తెలిస్తే then you can calculate the P of xj by yk and P of yk by xj so that we can calculate all the entropies. Okay, knowing the corresponding probability matrices, you can calculate the all the 5 different kinds of entropies of a communication system. Okay, ma, thank you.
Yes, thank you.
Okay, J4. Ma, J4, Punyavati.
Ma'am.
Ma, please write down the roll numbers I1, I2 and J2. Note చేసి ఉంచండి పక్కన.
Okay, ma'am.
Okay. So now let us move to the relationship between the joint, conditional and marginal entropies. Here I told you that here we know the basic expressions of marginal entropies, conditional entropies and joint entropy. Basic equations we studied. In the last slide only you have seen all these expressions. But how to relate h of x, h of y, h of xy, h of x by y and h of y by x? Is there any relation to is there any relation between all these entropies? Okay, so let us see how all these are interrelated. See here you can see two relations. One is h of xy is h of x by y plus h of y. And a joint entropy is equal to conditional entropy h of x by y plus h of y. So I think you know that h of x, h of y are marginal entropies, h of x by y and h of y by x are conditional entropies, and h of xy is a joint entropy. So these the below shown equations represents the relation between the joint entropy, the two kinds of conditional entropies and two kinds of marginal entropies. Okay, so in your examinations you are supposed to prove the two relations. అంటే మీకు ఎలా అడుగుతారంటే స్టేట్ అండ్ ప్రూవ్ ద బిలో షోన్ టూ రిలేషన్స్ అని చెప్పి అంటారు. ఓకే, సో ఇట్స్ గివెన్ లైక్ హెచ్ ఆఫ్ ఎక్స్ వై ఈస్ హెచ్ ఆఫ్ ఎక్స్ బై వై ప్లస్ హెచ్ ఆఫ్ వై and h of xy is h of y by x plus h of x. And another thing is even in your objective exams you may choose the correct relation in the objective multiple choice questions. Okay, please remember these two equations and let us see how to prove these two relations. Okay, so in the next slide you can see the proof of the first relation, that is h of xy is h of x by y plus h of y. Okay, so already I told you that h of xy, it's all, you can also represent it as h of x comma y, both are same. Okay, sometimes you can represent comma or there is no need of representing the comma, both represents the same. Okay, so please see the let us prove the relation. Now what is h of xy? I think you know the definition for h of xy. What is the definition? So in order to prove these things, take LHS, take the left hand side part, that is h of xy. Okay, from the definition of joint entropy, what is h of xy? Joint entropy. From the definition of joint entropy, I think you know that it can be expressed as minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of xj comma yk log p of xj comma yk base 2. Okay, so this is the corresponding relation. Now please observe that LHS equation carefully, and I think if you can easily observe, you can observe the blue lines indicated here. Okay, here if you observe the portion inside the logarithm, that is p of xj comma yk. Here LHS is xy, but if you observe the RHS part, okay, RHS consists of h of x by y plus h of y. అంటే మీకు logarithm part, if you observe, this is a joint probability matrix. ఇక్కడ మీరు ఏ టైప్ ఆఫ్ ప్రాబిలిటీ మ్యాట్రిక్స్ కింద రిప్రజెంట్ చేయాలి? p of yk and p of xj by yk ఫామ్ లో రిప్రజెంట్ చేయాలి. దెన్ యూ కెన్ స్ప్లిట్ ద logarithm. Okay, that's why first we took the LHS part, that is h of xy. So దానికి బేసిక్ ఈక్వేషన్ రిప్రజెంట్ చేస్తారు. Now please observe the part inside the logarithm, that is p of xj comma yk. Please recollect the Bayes theorem. What Bayes theorem states? It gives the relationship between joint probability matrix, alane marginal probability matrices and conditional probability matrices. That is p of xj comma yk is p of xj into p of yk by xj, or you can also equate it to p of yk into p of xj by yk. Just replace p of xj comma yk as p of yk into p of xj by yk. Why only this? Why not this p of xj into p of yk by xj? Because we are not representing by using the second term. First term kinda replace chestunaru. Endukani? Because if you observe the RHS here, you need to represent as h of y and h of x by y. If you observe this equation, you have yk and x by y. So andukani cheppi replace our joint probability matrix in terms of p of yk into p of xj by yk. If you want to prove the second relation, you should replace this p of xj yk as the p of xj into p of yk by xj. Okay, so now please replace this p of xj comma yk using p of yk into p of xj by yk. Now please substitute equation 2. అంటే ఏంటి? p of xj comma yk is p of yk into p of xj by yk. Please substitute this in equation 1. Then h of xy is equal to minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of xj comma yk into log, the term inside the logarithm we are changing. How we are changing? Into p of yk into log p of xj by yk. Okay, just ఈ ఇంటర్నల్ టర్మ్ ని ఇలా రీప్లేస్ చేసుకుంటున్నారు యూజింగ్ బేయిస్ థియరం. సో వై ఓన్లీ ఫస్ట్ టర్మ్, సెకండ్ టర్మ్ ఎందుకు రీప్లేస్ చేయట్లేదు? బికాజ్ ఇఫ్ యూ అబ్జర్వ్ ద ఆర్హెచ్ఎస్ టర్మ్, it's only related to the term which is shown in the first one, that is p of yk into p of x by y. So logarithm internal term replace చేశారు. Okay, good. Now this is in the form of log a b, log of ab. So log ab ni ఎలా replace చేయొచ్చు? Log a plus log b. So log of a into b, you can write it as log a plus log b. So please split the logarithm. Split the term using the logarithm function. Okay, first ఏం చేశారు? We took LHS part. So corresponding equation రాసుకున్నారు. Next ఆ joint probability matrix ని ఎలా replace చేయొచ్చు using Bayes theorem? You can replace it as p of yk into p of xj by yk, or p of xj into p of yk by xj. మీకు ఇక్కడ RHS లో whatever the thing you want to define, the correspondingly you are defining the probability matrices. అంటే p of y, p of x by y. So that's why we are replacing like that. Replace చేసి ఏం చేశారు? Now it is in the form of log a into log b. So now you have to split it into two terms. So log a plus log b. Okay. So in the next slide, we'll split this the term inside the logarithm using like log a, log ab will be log a plus log b. Now split the equation. So here we have log AB base 2. Now how can you split? Log A plus log B. But actually here you have negative sign. మనకి ఇక్కడ negative sign ఉంది. So ఇప్పుడు ఈ term ని split చేస్తున్నారు and you have negative term. So if you split this, you will get log P of yk base 2. That is the first term. Okay, and log B is log P of xj by yk base 2. So that is the second term. Please write this. Just we split log AB base 2 into log A base 2 plus log B base 2. Okay, so already we have minus summation j is equal to 1 to m summation k is equal to 1 to n p of xj yk. That term is common. So finally you will get first term using log p of yk base 2 and second term using log p of xj by yk base 2. Okay. Now please observe the second term. What is the second term? What is the second term? Any one of you, please tell me what is the second term? Can you tell me this equation is for which kind of entropy? Any one of you, please tell me. So this equation is for which kind of entropy? Any one of you, please tell me this equation is for. So this is the expression for which kind of entropy?
Conditional entropy, ma'am.
This is conditional entropy. Okay. So conditional entropy, can you tell me which kind of conditional entropy it is?
H of x by y.
Can you tell me what is h of x by y?
By knowing the receiver y elements and evaluating the parameters of transmitter x.
Okay, ma. Okay. Thank you very much. Thank you. Okay. So this second term represents the conditional entropy of calculating the transmitter parameters by knowing the information of receiver events. Okay. So this is the second term. So directly we replace the second term as h of x by y. Now please observe this first term. Now you have to replace this in the form of h of ఏ ఫామ్ లో రిప్రజెంట్ చేసుకోవాలి మనకు RHS ఏంటుంది h of x by y plus h of y ఉంది. సో దీన్ని మీరు h of y ఫామ్ లో రిప్రజెంట్ చేయాలి. వాట్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ h of y? మీరే చెప్పండి. కెన్ యూ టెల్ మీ వాట్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ h of y?
Minus summation k equals to 1 to n p of yk into log p of yk base 2.
Now how can you get here p of yk? Already I have given you one relation. So by using that relation,
joint entropy.
By using the relation between marginal probability matrix and joint probability matrix, you can replace summation j is equal to 1 to m p of xj comma yk as okay. I will show you, no problem. Here you can see. So second term we replace as h of x by y. Now if you observe the first term carefully, here summation j is equal to 1 to m p of xj comma yk అంటే ఇక్కడ j ని కంప్లీట్ గా రీప్లేస్ చేస్తున్నారు అంటే x ని రీప్లేస్ చేసేస్తున్నారు సో you will get p of yk only the p of yk value already second or third slide I have given this relation p of yk is summation j is equal to 1 to m p of xj comma yk so please you write this expression. So using this relation, you can replace it as p of yk. ఇక్కడ k term వస్తుంది ఎందుకని j ని రీప్లేస్ చేస్తున్నారు సో యు ఆర్ రీప్లేసింగ్ j term అంటే x events so then you can get the marginal probability matrix which is p of yk which you can obtain it as summation j is equal to 1 to m p of xj comma yk. So just this corresponding terms represented in the blue rectangular box I have replaced as p of yk. Replace that. If you replace this whole as p of yk, మనకి ఫైనల్ గా వచ్చే టర్మ్ ఏంటవుతుంది మైనస్ సమ్మేషన్ k is equal to 1 to n p of yk into log p of yk base 2. Okay, so upon rearranging, upon replacing p of yk upon replacing summation j is equal to 1 to m p of xj comma yk using p of yk, h of xy will be minus summation k is equal to 1 to m p of yk into log p of yk base 2 వస్తుంది మీకు. This term is nothing but marginal entropy of the receiver. This term is nothing but the marginal entropy of a receiver section. So that's why you can replace it as h of y. So h of x by y plus h of y. This is nothing but the relation what I have shown you. Just we consider the RHS term and we replace the function inside the logarithm. Probability p of xj comma yk ni replace చేస్తారు using Bayes theorem. Then we'll split the logarithm function. Split చేసిన తర్వాత directly we can replace the conditional entropy. So marginal entropy ఎలా వస్తుంది by using the relation between marginal probability and conditional probability you can replace it using h of y. That is the marginal entropy. Okay, now let us go to the second relation. Okay, I think you have completed this. Let us move to the next slide. So let us go through the proof of second factor. So these two derivations are very important for your examination. Okay, so what is the second relation? H of xy is equal to h of y by x plus h of x. First relation is h of xy is equal to h of x by y plus h of y and r. And the second relation is h of y by x plus h of x. By using this also you can rewrite. Okay, so once again we'll in order to prove this once again we'll consider the LHS definition. So what is the definition for joint entropy? So this is the second proof. So take the once again LHS, that is h of xy which is minus summation j is equal to 1 to m summation k is equal to 1 to n p of xj comma yk log p of xj comma yk base 2. Okay, so మనం ఫస్ట్ ప్రూఫ్ డెరైవ్ చేసేటప్పుడు ఏం చేసాము we replaced p of xj comma yk using p of yk and p of xj by yk. This is because we need to represent that in the form of h of y and h of x by y. But ఇక్కడ మనం ఎలా రిప్రజెంట్ చేయాలి h of y by x and h of x. So that's why we'll use the second relation. What is the second relation? P of xj comma yk, you can replace it as p of xj into p of yk by xj. Now please replace the joint probability matrix in terms of P of xj into P of yk by xj. So ఇక్కడ మీకు h of x కావాలి కాబట్టి P of xj ఫార్మ్ లో రిప్రజెంట్ చేయాలి. And you have h of y by x. So please represent it as P of yk by xj. So after replacing this, please substitute equation 2 relation in equation 1. Okay. Please substitute equation 2 relation in equation 1. Then what we'll do? So we'll have same minus summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk log ఏంటి వస్తుందమ్మా? If you substitute equation 2 in equation 1, log P of xj into P of yk by xj base 2. Log P of xj into P of yk by xj base 2. Now you have once again it in the form of log a log b. So next what ఏం చేయాలి? Say use the same procedure. So can you tell me what is the next step? Please split it into log a plus log b. Okay. So let us move to the next slide. Just we substituted the relation using Bayes theorem into the joint entropy expression. So ఇక్కడ మీరు RHS ఏంటో చూసుకొని జాగ్రత్తగా accordingly you use either first relation or second relation. Now let us move to the next slide. So ఇక్కడ ఏం చేస్తున్నాం మనం? Now you are going to split the above equation. So ఎలా split చేస్తారు? You have log a b base 2, log ab base 2. Okay, you can split it as log a base 2 plus log b base 2. So accordingly you ila split cheste, then you have two terms. So in the first term you will have log p of xj base 2, and in the second term you have log b base 2 kada, log p of yk by xj base 2 వస్తుంది ఇక్కడ. So first term is minus summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk log P of xj base 2. And second term is minus common ఉంటుంది ఎందుకు? Here you have negative sign in the original equation. So minus summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk log P of yk by xj base 2. So can any one of you tell me this equation is for which kind of conditional entropy? Any one of the student? I request any one of the student to please tell me please observe the second term and tell me that this is the expression for which kind of conditional entropy. So conditional entropy అని తెలుస్తుంది ఎందుకని? Because by using two different kinds of probability matrices you are calculating the entropy. One is joint probability matrix and other is the corresponding conditional probability matrix. Can any one of you tell me what is the kind of conditional entropy? The second term, using second term you can calculate which kind of conditional entropy.
H of y by x.
H of y by x. What is h of y by x?
Evaluating the parameters of receiver y by knowing the transmitter parameters x.
Okay. So in order to calculate the corresponding conditional entropy, how many probability matrices you need?
2.
ఏంటంటమ్మా?
Joint probability matrix and corresponding conditional probability matrix.
Okay, thank you. Second term అయిపోయింది. First term ని ఎలా రీప్లేస్ చేయొచ్చు? Do you have any idea? because already I told you the same derivation. So ఇప్పుడు మీకు ఫస్ట్ టర్మ్ ఎలా రావాలి, h of x రావాలి. What is the expression for h of x?
minus summation j equals to 1 to m p of xj log p of xj base 2.
అంటే మీకు ఇప్పుడు ఇక్కడ సమ్మేషన్ k is equal to 1 to n p of xj, yk రీప్లేస్ అవ్వాలి.
Yes.
దాన్ని ఎలా రీప్లేస్ చేయొచ్చు?
p of xj is equals to summation j equals to 1 to m p of xj yk.
ఓకే 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 అమ్మా, థ్యాంక్ యూ. ఓకే, సో ఇక్కడ మీరు ఏం చేశారు, సెకండ్ టైం డైరెక్ట్లీ వి రీప్లేస్డ్ యాజ్ h of y by x. సో సెకండ్ ఈక్వేషన్ రిప్రజెంట్స్ ద conditional overall conditional entropy of calculating the receiver parameters knowing the transmitter events. Okay, so directly we replaced. But first term పరిస్థితి ఏంటి, we need to represent it as h of x. ఎందుకు RHS లో మనకి ఏంటుంది, h of y by x plus h of x ఉంది. So first term you need to replace it as h of x. Okay, so if you observe the equation first term carefully, here you have summation k is equal to 1 to n p of xj comma yk. Here if you replace this k is equal to 1 to n, yk can be, you can exhaust that. Okay, so that you can get only the marginal probability matrix. Okay, the relation is shown like p of xj is equal to summation k is equal to 1 to n p of xj comma yk. So you can replace this whole value as p of xj. Now upon replacing using p of xj, h of xy will be minus summation j is equal to 1 to n p of xj log p of xj base 2. This is nothing but the marginal the marginal entropy of the transmitter section. So this is the marginal entropy of transmitter events capital X. Okay, so finally we obtained h of xy as h of y by x plus h of x. So these two relations are very very important for your examination. State and prove అని చెప్పి ఈ two relations ఇస్తారు. 3 more relations are also there like this, using the mutual information. Okay, so please remember the procedure to solve or prove these two relations. So these two relations, once again I am moving to the same slide. So these two relations gives you, okay, these two relations gives you the information about the joint entropy, conditional entropy, and two kinds of conditional entropies and two kinds of marginal entropies. Okay. Next, let us move to the new concept, namely mutual information. So, exams ki those two bits are very very important. Okay, now let us move to the concept of mutual information. So before going to mutual information concept, I request any one of the student to please tell me the expressions for the 5 kinds of entropies and the two relations between the two conditional entropies, two marginal entropies, and joint entropy. So any one of the student. Laterality 22. Can you tell me the expressions for 5 kinds of entropies and the two relations between the 5 kinds of entropies? అమ్మా చెప్తారా?
మార్జినల్ ఎంట్రోపీ మ్యామ్
అమ్మా చెప్తారా?
చూసుకోండి మేడం.
అమ్మా వాట్ యు వాంట్?
ఈక్వేషన్స్ మేడం.
ఈక్వేషన్స్ 5 ఈక్వేషన్స్ అలానే 2 రిలేషన్స్ ప్రూవ్ చేసాం కదా మనం.
ఎస్ మ్యామ్.
డూ యూ వాంట్ దట్ స్లైడ్?
I will say ma'am. I note down a note madam.
Okay. Then please continue.
Marginal entropy of transmitter h of x is equals to minus summation m is to j is equals to j is equals to 1 p of x of j dot log 2 p of x of j madam.
Okay.
For marginal entropy receiver h of y is equals to minus summation n2 k is equals to 1.
Okay. K is equal to 1 to n.
1 to n.
Okay.
P of y of k dot k into log 2 p of y of k madam.
ఒకసారి ఉండండి. Once again I am telling all of you that while pronouncing log మీరు ఫస్ట్ బేస్ 2 ప్రొనౌన్స్ చేస్తున్నారు. ఓకే, సో ప్లీజ్ ప్రొనౌన్స్ ద ఫంక్షన్ ఇన్సైడ్ ద లాగర్థమ్ అండ్ దెన్ టెల్ ద బేస్. అంటే లాగ్ p ఆఫ్ y కే బేస్ 2 అని చెప్పాలి. ఇస్ ఇట్ ఓకే?
ఓకే మేడం.
అంటే లాగ్ బేస్ 2 చెప్తున్నారు కదా ఫస్ట్, నాట్ ఓన్లీ యూ, అంటే అందరూ అలా చెప్తున్నారు. లాగ్ 2 ఫస్ట్ చెప్పకూడదు, బేస్ చెప్పకూడదు. లాగ్ p ఆఫ్ y కే బేస్ 2, లైక్ దట్ యూ నీడ్ టు ప్రొనౌన్స్. ఓకే, కంటిన్యూ.
Joint entropy.
Okay.
H of x into y is equals to minus summation m to j is equals to 1 summation n to k is equals to 1.
అమ్మా ఒక్కసారి, సారీ ఫర్ ద ఇంటరప్షన్. యాక్చువల్లీ యు ఆర్ టెలింగ్ లైక్ సమ్మేషన్ m to j is equal to 1 అంటున్నారు కదా. సో రివర్స్ చెప్తున్నారు, j is equal to 1 to m, అంటే డినామినేటర్ టు లైక్ లోవర్ వాల్యూ టు హైయర్ వాల్యూ కదా ప్రొనౌన్స్ చేయాలి.
Yes ma'am.
So whatever you are telling is equation is right, but instead of saying m to j is equal to 1, you should pronounce like lower level to higher level. At j is equal to 1 to m, summation k is equal to 1 to n. రాసేటప్పుడు ప్రాబ్లం ఉండదు, బట్ వైల్ ప్రొనౌన్సియేషన్ యూ షుడ్ టెల్ ఫ్రమ్ లోవర్ వాల్యూ టు హైయర్ వాల్యూ. ఓకే ఓకే అమ్మా, కంటిన్యూ.
Joint entropy h of x comma y minus summation j is equals to 1 to m summation k is equals to 1 n p of x of j comma y of k into log of p of x of j comma y of k base 2.
Okay.
In conditional entropy of transmitter knowing receiver data h of x comma y is x divided by y is equals to minus summation j is equals to 1 to m summation k is equals to 1 to n p of x of j comma y of k into log p of x of j divided by y of k into base 2.
ఇంకా ఎక్స్ ఆఫ్ అని చెప్పక్కర్లేదు, ఎక్స్ జే అనేది, అంటే ఎక్స్ సఫిక్స్ జే.
x suffix j.
ఓకే.
For conditional entropy of receiver knowing transmitter data h of y divided k y divided x is equals to minus summation j is equals to 1 to m summation k is equals to 1 n p of x of j comma y of k dot log into
log p of yk by xj base 2
of k by xj into base 2.
Okay, very good. Now can you tell me the relations between the 5 kinds of entropies of a communication system?
H of x into y is equals to h of x mod by
x by y అని చెప్పేయండి పర్లేదు. x by y
plus h of y and h of x into x, h into x comma y is equals to h of y, y by x plus h of x.
Yes, yes. Very good, very good. Okay, can you tell me the, are you comfortable to tell me the proof of any kind of relation? చెప్తారా? ఆల్రెడీ నేను ఇప్పుడు చెప్పాను కదా, ఒకసారి రిపీట్ చేస్తారా? Are you comfortable?
I will try, madam.
Okay, I will show you the slides. Is it visible to you?
Yes, ma'am.
Okay, okay, please go through this and tell me.
First, we will write the joint entropy equation. From Bayes theorem, we will divide the Bayes theorem. We divide the terms like v of x terms and y terms, madam.
We can define this internal term joint probability matrix into either p of yk into p of xj by yk or p of xj into p of yk by xj. ఇక్కడ మీరు RHS టర్మ్స్ ఏంటున్నాయి? h of y plus h of x by y కదా.
Yes, ma'am.
సో అంటే ఏ రిలేషన్ తో ఈక్వేట్ చేయాలి?
P of
yk into
p of
xj by yk. సో మీరు ఇప్పుడు ఇంటర్నల్ గా చూసుకోండి, yk అంటున్నారు అంటే y ఈవెంట్స్ అన్ని ఉన్నట్టు, xj by yk అంటే x by y అన్ని ఈవెంట్స్ ఉన్నట్టు. ఓకే, అదే ఇప్పుడు సెకండ్ టర్మ్ చూసుకుంటే x ఈవెంట్స్ ఉన్నాయి, ఇక్కడ x ఈవెంట్స్ ఏం లేవు కదా, అలానే yk by xj ఈవెంట్స్ కూడా ఏం లేవు. సో అందుకని ఫస్ట్ టర్మ్ తో రీప్లేస్ చేస్తారు. ఇక్కడ సబ్స్టిట్యూట్ చేసి యూ విల్ గెట్ దిస్ ఈక్వేషన్. ఓకే, ఓకే, నెక్స్ట్ స్టెప్ ఏంటి? ఓకే, సబ్స్టిట్యూట్ చేస్తారు. వాట్ ఈస్ ద నెక్స్ట్ స్టెప్? What is the next step?
xy terms. Splitting of xy terms, madam, with me.
Okay, split చేశారు అంటే log ఫస్ట్ టూ ఫంక్షన్స్ ఉన్నాయి, log ఆఫ్ టూ ఫంక్షన్స్. సో log ab ఎలా రాసుకోవచ్చు? log a plus log b.
Yes, ma'am.
ఓకే, స్ప్లిట్ చేశారు. తర్వాత ఏంటి?
We will get for conditional entropy of receiver.
Yes, yes. Second term direct గా conditional entropy of transmitter knowing the receiver data. ఓకే, ఫస్ట్ టర్మ్ ఎలా రీప్లేస్ చేయొచ్చు?
h of x by y, madam.
ఓకే, సెకండ్ టర్మ్ h of x by y రీప్లేస్ చేశారు. ఓకే, గుడ్. ఫస్ట్ టర్మ్ okay, no problem, you can take time.
Second equation for knowing transmitting data, madam.
Okay, సెకండ్ ఈక్వేషన్ కాదు, ఫస్ట్ టర్మ్ ఫస్ట్ రిలేషన్ లోనే ఫస్ట్ టర్మ్ ఎలా రీప్లేస్ చేయొచ్చు?
h of x by y, madam, and p of yk equation.
Okay, okay, ఫస్ట్ టర్మ్ ఎలా రీప్లేస్ చేశారంటే హియర్ యూ హ్యావ్ రీప్లేస్డ్ సమ్మేషన్ j is equal to 1 to m p of xj comma yk. We replaced it as p of yk. Okay, so finally you will obtain it as minus summation k is equal to 1 to m p of yk log p of yk base 2. That is nothing but the marginal entropy of the receiver section. So finally we obtained h of xy as h of x by y plus h of y. Okay, so in the same model, if we replace joint probability matrix with p of xj into p of yk by xj, you will get a relation between h of xy as h of y by x plus h of x. Okay, ma, thank you. Very good. And thank you. You can mute yourself. Now let us move to the new concept, namely mutual information. I think this is the last module. This is the last concept of the first part of Unit 4. So after completion of this mutual information and its properties, we can see very important problems regarding the calculations of all the kinds of entropies and mutual information. Okay, please all of you listen carefully. This concept is very important. జాగ్రత్తగా వినండి. So what is mutual information? First, before going to the definition, it is represented as capital I of x comma y. మనం ఎంట్రోపీ h తో రిప్రజెంట్ చేశారు కదా. సో మ్యూచువల్ ఇన్ఫర్మేషన్ ఈజ్ రిప్రజెంటెడ్ విత్ ఎ లెటర్ I of xy. అన్ని క్యాపిటల్ లెటర్స్. సో I of xy. Now let us derive the expression for this mutual information. Okay. Now as usual, అంటే మనం ఇంతకు ముందు కన్సిడర్ చేసుకున్నట్టే, let us consider the transmitter events as xj, where j ranges from 1 to m. Okay, let p of xj be the transmitter probability of event xj. Okay, now here we are defining the probability of transmitter event as p of xj. P of xj ఏంటమ్మా? Probability of the transmitter events where j ranges from 1 to m. Now here you should consider the probability of the transmitter events. You can define it in terms of two conditions. One is without knowing the information of receiver, or with knowing the information of receiver. అంటే మీరు ట్రాన్స్మిట్ చేస్తున్నారు, బట్ యూ డోంట్ నో వెదర్ ద డేటా హ్యాస్ రిసీవ్డ్ ఆర్ నాట్. ఓకే, అంటే ఎంత ప్రాబిలిటీ రిసీవ్ అయింది, వాట్ ఈస్ ద ప్రాబిలిటీ, కరెస్పాండింగ్ ప్రాబిలిటీ. ఓకే, సో బేస్డ్ ఆన్ దట్ ఇన్ఫర్మేషన్ we can define the probability of transmitter events as either p of xj or p of xj by yk. Here p of xj is the transmitter, that is the probability of transmitter events. Here divided by అదేం మెన్షన్ చేయలేదు కదా మనకి. So that type of probability is generally like without knowing the information. Without knowing the information whether that how much amount of data has received at the destination point. Okay, then that kind of probability is generally called as priori probability. Priori probability, and here we don't have any information about the received data, and how much information has received, that part you don't know. Okay, so without knowing the information of received data, at yk information you don't know, then if you are defining the probability of transmitted data or transmitted events, that is called as priori probability of the transmitted events. So p of xj is the priori probability of the transmitter events. Okay, and p of xj by yk, remember both the probabilities are for the transmitter events only, but first one is without knowing the information of receiver data, and the second term represents the posteriori probability. Here posteriori probability ante after knowing the information of received data. After knowing the information of received data, if you are calculating the information about the transmitted events, then it is called as p of x, it's called as posteriori probability. So priori probability ante without any information of the received data. So ikkada receiver ane kaadu, ikkada మీరు transmitted data transmitted probability define చేస్తారు. In the similar fashion, if you are defining the receiver probability, appudu P of yk avutundi. P of yk is the receiver priori probability and P of yk by xj is the receiver posteriori probability knowing xj information. So priori probability ante without knowing the information, we are defining the probability of the corresponding event. So transmitter priori probability is P of xj. Here we don't know any information of yk. If you know the information of yk ante divided by yk పెట్టారు చూడండి. P of xj by yk represents the transmitter posteriori probability knowing the information of yk. Okay, so P of xj is transmitter priori probability. P of xj by yk is transmitter posteriori probability knowing the information of receiver ante yk. So I think now you understood what is the main difference of priori probability and posteriori probability. So what is the priori probability? P of xj. So it's the probability of the transmitted information or transmitted events without having any information of the receiver. And P of xj by yk is the transmitted posteriori probability knowing the information of receiver events. Okay, but always remember that both are the probability of the transmitted events. Now, mutual information. Now we are going to define the mutual information. Generally, it is defined as the difference between the two uncertainties due to priori probability and posteriori probability. Okay, so please listen the definition for mutual information. It is defined as the difference between two uncertainties due to priori probability. What is the priori probability of transmitter? P of xj. And what is the posteriori probability of transmitter? P of xj by yk. Okay, so the difference between the two uncertainties is generally defined as the mutual information. So what is mutual information? It is defined as the difference between the two uncertainties due to the priori probability and posteriori probability of the transmitter section or receiver section. So we ikkada P of xj and yk and P of xj by yk తీసుకోవచ్చు, or else receiver consider చేసుకుంటే P of yk and P of yk by xj consider చేసుకోవచ్చు. But here I took the example of the information from the transmitter. Okay, so I have written here I of xj comma yk, mutual information due to xj events and yk events. It is defined as uncertainty అన్నా ఉన్నాం మనం ఇక్కడ, difference between two uncertainties due to P of xj and P of yk. Please recollect the point what I stated in the module 1. So information is always proportional to the uncertainty and it is equal to log P of log the corresponding probability base 2. Okay, so difference between the two uncertainties due to P of xj and P of xj by yk. P of xj is priori probability and P of xj by yk is transmitter posteriori probability knowing yk. So the difference between the two uncertainties is called as mutual information. So ఇప్పుడు మీకు I of xj, what is the definition for that? Information is proportional to uncertainty అని చెప్పాం and it is equal to. So we have derived this in the first module. So log 1 by p or minus log p base 2. So అదే రిప్రజెంట్ చేశారు ఇక్కడ. So I of xj is equal to minus log p of xj base 2 or దీన్ని ఎలా కూడా రాసుకోవచ్చు log 1 by p of xj base 2. Now in the same manner I of xj by yk is the transmitter posteriori probability, transmitter posteriori information. Okay, so ikkada manaki enti what's the point that you should remember here? Uncertainty is proportional to the information or information is proportional to uncertainty and it is inversely proportional to the probability అని చెప్పాం. Okay, so I of xj by yk, it's proportional to uncertainty and it is equal to minus log the corresponding probability enti manaki ikkada p of xj by yk base 2. So consider the definition as equation 1 and the two uncertainties as equation 2. Okay, now what is I of xj comma yk? Please observe that this is not I of xy, this is I of xj comma yk. Average of all the values gives you the overall mutual information I of capital X capital Y. The thing shown here is not the overall mutual information. This is due to the events of xj and yk. The average of all the values gives you the overall mutual information I of x comma y. Okay, so I of xj comma yk, if you observe this, please substitute the uncertainties of I of xj and I of xj by yk which are shown in the equation 2 in equation 1. So please substitute here. Then you will get it as I of xj comma yk is equal to minus log p of xj base 2 minus of minus. So already you have negative here and you have one more negative for the uncertainty. So minus of minus it will be plus log p of xj by yk base 2. Now this is in the form of log a minus log b. So log a minus log b, you can represent it as log. So this is chudandi minus log a plus log b and then it will be log b by a. So b is p of xj by yk divided by a is p of xj. Okay. So this is the equation for mutual information due to the events xj and yk. So average of all the values gives you the overall mutual information capital I of x comma y. Okay, so what is the expression for I of xj comma yk? The respective events. It is log p of xj by yk divided by p of xj. So this is the transmitter mutual information. Now any one of you, can you tell me what is the receiver? అంటే నాకు I of yk comma xj చెప్తారా ఈక్వేషన్? This is the information whenever the data is sent from transmitter to receiver. So if I want the mutual information from receiver, if receiver want to send the acknowledgement to the transmitter, that is I of yk comma xj. So can you use the same procedure and can you tell me what is the expression for that? Naku I of yk comma xj expression cheppandi. Any one of you. So this is a mutual information whenever the information is transmitted from the transmitter section to the receiver section. For example, if the receiver wants to send the acknowledgement to the transmitter, then the mutual information of the receiver will be the corresponding probability will be P of yk is the receiver priori probability and P of yk by xj will be the receiver posteriori probability. So use the same procedure, and can any one of you tell me what is I of yk comma xj? Mutual information due to the receiver section. Any one of you?
Log P of yk by xj by
Okay.
P of yk base 2.
Log P of yk by xj divided by P of yk base 2. Okay,
Base.
very good. Okay. Now I request all the students to please derive the same expression. ఒకసారి అందరూ derive చేయండి. I will give you 2 to 3 minutes time. So make use of the same procedure and calculate the mutual information of the receiver events. So ఎలా స్టార్ట్ చేస్తారు? Let P of yk be the receiver probability of event yk and P of yk is the receiver priori probability. P of yk by xj is the receiver posteriori probability knowing xj. So use the same procedure and tell me the mutual information due to the receiver events. Please try to solve that. Take 2 minutes time. So it's 3:43. Take 2 minutes time and complete the derivation, and you should get it as I of yk comma xj as log P of yk by xj divided by yk అని చెప్పి రావాలి మీకు base 2. Okay, solve this procedure and I will give you 2 minutes time. అంటే మీకు I of xj comma yk is the mutual information of the transmitter events and I of yk is the mutual information of the receiver events. So once you know the two corresponding equations, automatically we can so when we discuss the properties of mutual information, you will be more comfortable. So just make I of xj comma yk and I of yk comma xj equations, both the equations you should remember. Complete చేయండి సెకండ్ మోడల్ కూడా. Okay, how many of you completed the same derivation? Please raise your hands. How many of you have completed? Please raise your hands. మా చేస్తున్నారా లేదా? How many of you are at least doing that derivation? Please raise your hands. Nobody has raised their hand. Okay, meanwhile, I will take the attendance. Okay, try to solve that as a homework. P of, so get I of yk comma xj. Okay, follow the same procedure and solve for I of yk comma xj. I of xj comma yk is the information of the transmitted events. And please try to make use of same procedure and try to solve the mutual information of receiver section. Okay, so any doubts in the tomorrow, the next class, we can discuss the properties of mutual information and the related problems we can discuss. Okay, so ఇది కంప్లీట్ చేయండి మీరు ఈ పోర్షన్. మీరు I of yk comma xj, you please complete this. So any doubts till now? If you have any doubts, or else you can leave the class. I1, I2, are you there? I1 and I2.
Yes, ma'am.
Emma, so many times I called you. Why you did not respond? I2. I1.
Is stuck
J2.
type.
చెప్పండి I2. చెప్పమ్మా. J2, are you there?
Yes, ma'am.
Emma, last time I called you. Why you didn't respond? Ma, చెప్పండి చెప్పండి.
Hello ma'am. I had a network issue, ma'am.
Okay, ma. Okay, no problem.
Thank you.
Okay. Okay, now you can leave. If you have any doubts, you can ask, or else you can leave the class. Try to complete the work that I have given to you. Try to complete that.